Galileoscope or okay? Good number, but some. I have built one before. Of the same crowd. Okay, so we're actually going to try and build some here today. And I asked the people that have built them before, please feel free to help the people that haven't. We're going to do groups of three or four roughly to go through and build them. I'm going to give you a little background on it first, just so you know about it. This was created in 2009, the International Year of Astronomy, to celebrate 400 years since Galileoscope's historic observation. And one thing that's a common misconception, the goal of this was not to recreate Galileo's telescope. Galileo had lousy optics, a very small field of view, a diverging lens, a lot of chromatic aberration. It was really a pretty lousy telescope as far as they go. So the goal is not to recreate the telescope, but to make something that was about the same size, similar aperture, similar magnification, that had a good optical and mechanical design. Because you don't want people, one of the biggest problems that people who start astronomy is they get frustrated, right? Have a telescope that has poor optics and it's difficult to point, small field of view, and they get frustrated. So the goal is not to create a frustrating experience for people to get started in astronomy, or to create a good experience for people to get started in astronomy. So at the top you can see one of the picture of one of the Galileoscopes, the model of the Galileoscope that we are going to build today. Just to give you the final rundown of specs, don't take stuff apart too much yet. Don't work at too much, please. That's one of the rules here. You may start opening the box and maybe clear a spotting table, but don't work ahead. A lot of these lenses have specific ways they go in, and you'll put half the stuff together backwards if you try and work too far ahead. It's a 50 millimeter apprehensive, so 500 millimeter focal length, 4-element eyepiece, which is actually a colossal eyepiece, which Galileo does not have colossal eyepieces, obviously. A 2x Barlow lens. The eyepiece is actually a 20 millimeter eyepiece, which gives you 25 magnification. Galileo had scopes going up to about 30, so that's in his ballpark. The Barlow lens will give you a 50 magnification. Or you can use the Barlow lens as a Galilean eyepiece, which I don't necessarily recommend, but it's a good way to show the students what a lousy telescope Galileo had. So it definitely has an educational utility, but it's not necessarily great for observation. We can get some optics experiments, which we won't have time for today if you wish to go on too. Here's a couple of views of the telescope, both taken through the Galileoscope. Left one was taken by Anders Janssen, the first quarter moon. He was, I believe, in Norway near Oslo. The right is Saturn, which I took was one of the first Galileoscopes off the production line about 2 years ago. And Saturn's rings were almost dead on. And even with that on ring, you still get a decent view of the rings. That's a 25x view. Just with a cheap digital camera, probably very similar to the one you're using right here.
It's not cheap.
Oh, oh, that's a good one? But that's like $150 digital camera. You know, it's a fairly typical thing. That's a 2-year-old digital camera. It's probably better than what I use. Newer.
Joking.
And I just want to mention also right now, there's one thing I just got this summer. There's a company in space and receive called Learning Encounters. I think it's leoscience.com. And they're building something called the Cosmos camera. And it's actually a camera optimized to attach to the back of the Galileoscope. And you build it, snap together similar to the Galileoscope built. They sent me a marketing sample. I've just been testing it a little bit. And it's basically a webcam, 1.2 megapixel webcam. You can take movies and stack them and stuff. And the first results are promising. You know, the first results are promising. So I haven't had a chance to play with it too much, but it looks like it has potential. Only $60, so for a webcam for $60 for the Galileoscope looks like it has potential. So I'd recommend checking that out. But that's my first. I'm still testing it. I'm going to get more pictures hopefully when I get back and the first quarter moon comes back next week. So before we begin, as we go through and we're going to build the Galileoscope, touch lenses only by the edges. There's some tissue paper in there, so you can avoid getting fingerprints on them if you need to feel which shape, which side lens is concave and which side is convex. Hold it between the tissue paper so you don't get your fingerprints on it. The other thing I'm going to mention with this, when we use as students, we frequently go to the store and get like rubber cleaning gloves or something. Or sometimes you have to have a little bit more money to get those cloth gloves they use in chemistry labs sometimes. So you can actually use those so students won't get fingerprints on the lenses. So we have 10 Galileoscopes out here, one roughly at each table. So I'd like to start taking them out of the box. I always recommend opening the right side of the box if the printing is upright towards you. And the reason for that is on the right side of the box, you might notice there's 2 little holes. That just makes it easier to pull out. Go open the left side, it's no big deal. Go ahead and open the boxes. You can build a tower, something goes out of that table. You've all done it. Pass down some of that stuff. If you have to build it, you've got one over here. If you have built one, you can totally get all these put together, so we're going to be different ways. So if you have built one, you can build another.
Ladies and gentlemen, does anybody have any work clothes that we can give to Sue? Our fellow Nigerian is freezing.
Anybody else that wants to? Yeah, if you want to. Okay. So first thing I'm going to mention is you get these things out here. There's a little baggie of parts. Put this somewhere safe. So you put this somewhere safe, and then lift off that piece of cardboard to reveal the pieces beneath. We don't have a lot of time, so I'll probably go a little quicker build than usual here, but I know we have a lot of people who've done this before, so hopefully that won't be too much of a problem.
Experienced astronomers.
Experienced astronomers, yeah. And for the next part, I usually lift up by this little flap right here that I'm highlighting on here. Just lift that straight up, and that will reveal the two telescope tube paths in the bottom. Two big telescope tube paths. Go ahead and take out those two big telescope tube paths and you discard that bottom piece of the box. Go ahead and remove these. Hold them out.
Can I make a suggestion?
Yes.
Perhaps we follow this turn on this camera, and you could
Well,
use the table.
actually, he's got-
assembly. Oh.
No, the pictures there are good illustrations.
Okay.
Well, these are being broadcast on the. These are going over the internet as well right now. Yeah.
Yes. Okay. You have a step by step.
Yeah, this step by step. The whole thing is step by step. Yes. The whole thing is step by
I was
step.
worrying about people listening.
Yeah.
Yeah.
The same thing I was thinking, but that shows.
Yeah. Okay, so go ahead and take out these guys. You have all these parts here roughly. That all these parts at the bottom are in that little plastic bag. You shouldn't need to open that bag quite yet. I usually set these out. Don't take these out. The one thing I tell students is don't start taking all these parts out of here, because I'll be referring to this diagram. Say take part O. Unless you remember where part O is and memorize every single part, you might not know which part is which. So leave them in here. Don't take them out. You're going to set them out in front of you just like that.
This is on.
So the first one we're going to do is we're going to take one of these two big telescope tube paths, and they're slightly different. I usually use the one without the logo on it first, and set it on the table so it's facing left with the concave side facing upward. And I take this big lens. The big lens is actually in the bag. It's probably inside this. It's inside this cap right here. Inside the cap marked side is a little plastic baggie with some lenses in it. Go ahead and take that baggie out and start opening the lenses. There's actually 7 lenses in there. There's 1 big one and 6 tiny ones. Now, if you slowly open up that lens again, hold it by the edges, there's tissue paper. And if you look at it closely, you'll notice it's actually 2 lenses, not 1. And that little piece of, I need to measure out that little piece. There's a little piece of, thing looks like packing material, actually has 6 lenses inside it. Do not throw it away. Put it somewhere safe. Just open your big lens right now. We'll get those later. Open your next big lens. Look at it from the side. You'll notice there's actually 2 lenses glued together. Put together this one. And you'll notice that 2 lenses glued together. You'll also notice lenses are not symmetric. Okay? 1 lens is thin at the edge and 1 lens is thick. The lens that is thin at the edge goes toward the front of the telescope tube, i.e., this is the front, logging up the back. Make sure the lens is thin at the edge, goes toward the front. And put it in the slit right there. Fix my computer. And Connie and I will come around and just check and make sure that the lenses end up in the right orientation. If you get them backwards, it will degrade the image quality. The thin lens toward the front. And you're good. Anybody else want to put together? I stopped. But I told my 10-year-old granddaughter not. Okay. I think we got them almost all there. Okay, let's move on. Next step, I think I checked most of them. Connie's checking the last couple. We start easy in this. Next up, open the little plastic baggie. There's the nut. And in the same half of the telescope tube as the lens unit is, about halfway down, is the mounting. Nut goes in the mount. Make sure the nut goes, guys, nut. If you look closely, just quiet down a little bit, please. So I can add a little bit. Guys, quiet down a little bit, please. Boy, what a neurotic crowd. Actually, don't quiet down a little bit. Quiet down totally. If you look closely, there's actually a V shape there, and one of the points has to go down into that V. Which has a point in the nut going straight towards the tube and a point going straight down. If you have a flat side pointing up, when you go to put the stroke together, the two halves will not fit together properly. So the points have to go into those V's. Don't work ahead. It's in the little baggie. In that baggie part, I told you that right here.
The part with the sticker that says don't look at the sun.
Yeah, don't look at the sun sticker. Okay. Okay, so next up is going to be putting together the focuser tube. We need the two tubes marked E. The two tubes marked E. And if you look at them closely, this is important. They actually have a right way and a wrong way to go together too. There's actually a little thumb and groove here, which is kind of hard to see. The way I think it's easier to do it, at about on each of these has about an inch smooth at the end. Match up the smooth end to smooth end. About the rest of it's rough. So try that to put about an inch on the interior of each of them is smooth, and the rest of it's sort of textured. Match up the smooth side to the smooth side. So they're the same ends and put them together. And you can hold them together with two small O-rings. There's going to be two small O-rings you can use to put it together. Not the big one. Again, this is small. Two small ones. Use the big one. The focuser tube won't slide properly. Put together the focuser tube. Part E. Okay? See a lot of people getting that whole boat together.
So the only thing is we haven't done anything with the just the O-rings holding it together.
Like most people have the boat together. Your boat, let's take a look at this quick. You're supposed to have two little U-bends on it. Well, they're U's if you point the folks or two. Point those so they're up toward the ceiling, so they're like little U's. Next, you're going to take the clamp, which is part F. It has a lip on it on the inside. Hold that clamp to the lip, the narrow side, and toward the ceiling. Then you're going to push it over the O-ring. It's going to sort of hang out there like that. So you have this on there. Again, you want to keep pointing towards the U-bend. So always say U-bend towards the ceiling. Lift towards the ceiling. Then drop it off. All right. You don't see that. These guys you don't put the little, you have to put these guys on first, all together. Yep, right there. Those O-rings stretch out. Don't be afraid to stretch those O-rings a little bit to get them on there. You're not going to break them. I've never broken them. Push it over the O-ring. Might have to push it a little bit. Let's push it just a little bit, slide over the O-ring, but it does go over. Yeah, get that in right there. You got it. You got it. Okay? Next, we're going to take this focuser tube we just assembled. Instead of gently inside this main tube here, the U-bends point towards the outside. The U-bends point outside. The one trick is there's not an exact place to set it, but you do want to make sure that the front of this is beyond this first little baffle here. This is what keeps you from pulling out that focuser accidentally. Make sure the front of it is just in front of here. You're about right. The front of the focuser tube goes right about in front of there. Don't make sure it's in front of here. Just make sure you don't pull it out. Pull it out. Here, then you won't be able to push it in. Keep pulling it out. It's about right there. You got help. You got the master.
Last time I did was
looks like this side is all pretty good over here. How's this side doing? Okay, well next up is something we're already surmising. Take your second telescope tube half, put it over the top, make sure it's all lined up nicely. Then your second one, line up with the nut. Put it on. Once you're done there, slide that end to hold it together. The front may be a little bit open yet. That's okay. We'll put another clamp on the front and hold it together too. But before we do that, a lot of people like putting these other two big O-rings on first. These two big O-rings end up with those two little grooves right there. They do stretch a lot. Don't be afraid to stretch them. Okay, Barlow? I find the easiest way to put those O-rings on is to take your scope. I put it on the table like this. Then just take the O-rings, stretch them out nice and far. Like I said, they stretch far, so it's very easy to just stretch them. Don't be shy, it's the key. Don't be shy about stretching them. I'm fairly large. I don't have problems. And then when you get those two O-rings on, then go ahead and take this other light shade and put it on the front to hold the front together. Now it looks like a telescope. Picture something starting to look like a telescope. Okay. I think I see almost everyone has this. One or two groups still working. Now we're going to start to the color part though. Eyepieces. Little bitty, teeny tiny pieces. This guy right here is where all your. This guy right here is where you have all your small lenses. This little piece of styrofoam that came with it. Carefully open it. Carefully take that tape off. Don't try and rip it. There's 6 teeny tiny lenses in here. You just rip it, those 6 teeny tiny lenses may fly everywhere. You'd like to find 4 teeny tiny lenses after that.
Anybody need a teeny tiny pair of scissors?
If you have a teeny tiny pair of scissors, that also helps. Oh, I almost forgot one thing. Very important thing I almost forgot. There's a sticker in here, right? What that sticker tells you not to do what? Don't look at the sun. So go ahead and put the sticker on the tube at this point. Now, some people ask about using the Galileoscope for solar projection. And you can actually point at the sun and put a piece of paper behind the eyepiece and project the image of the sun. That works with conventional telescopes. However, I should warn you, the eyepiece of the Galileoscope is made of plastic. When you do that, the eyepiece of the Galileoscope will get very hot. And when plastic gets very hot, you might melt your eyepiece. Even solar projection, I don't recommend with the Galileoscope.
I did that with a regular lens. I finished it off. I was like, after the projector in, smoke came out of the lens.
Yeah, so if you want to regular telescope, got to be careful.
Beautiful.
Yeah, if you have telescope, if PVC and Bayer films, you make a solar filter. You can, it does not overheat. It works just fine. It's great viewing. Yeah, Bayer film's good. Yeah, so for $5 or less, you can make it. Bayer Planetarium. That was a Bayer Planetarium Mylar solar film. If you get Bayer film, you can make your own little solar filter similar to that, and that works really well. That'll be fine. That filters out enough sunlight, your eyepiece will not heat up. That goes out like 99.999. Yeah, 99. I forget how many 9% light. Yeah. And then your eyepiece will be just fine. Won't be a problem. So eyepiece. There's 6 lenses in there. 4 big ones, 2 small ones you may have noticed. The 4 big ones are for the colossal. The 2 small ones are for the Galilean eyepiece. So we're going to need several pieces. We need 2 big eyepiece tube halves, which are parts K. This little bitty ring marked N is these 4 lenses right here. Don't take them out yet, because I'm going to show you which lenses are which. They pair up. Start finding these pieces right here. Find these eyepiece tabs. Find that little ring marked end. If you can't find the little ring marked end, it's way at the edge here. It's kind of hard to see. Right here. If you can't find the ring marked end, sometimes they fall down in here. Just tilt this way, they'll probably fly out the end. But you got it right here, so it's fine. Okay? So probably that little ring, you can figure out where the little ring goes because there's a little slot right there in your halves, right? So that little ring goes in the little slot. And for here, look closely. If you set this up, so the two small lenses are at the left, the four big lenses are at the right. The red lenses are double concave convex lenses. The blue lenses are plano concave. Set a plano concave lens on the table. Drop a double convex lens in it. So you match up the concave and the convex. Do that twice. So you got two of them. You do that twice. Again, use tissue paper if you need to, or hold it by the edges. I will give you one more warning. Some of these lenses have little pieces of tissue paper on them. Remove the tissue paper. Every time I do this, I get one eyepiece of tissue paper stuck between the lenses. Yeah.
Hey, you don't have an extra max power cord, do you? Or no, you can borrow mine for a while if you want. Can I?
And I'll show you the next step, and then you can, I'll come around and start looking at people.
Okay, I just need to. Okay, thank you. I will not have it for very long.
Two lenses go in each slot. There's two slots, so one pair of lenses goes in each slot. We'll come around and check these before you put them together to make sure they're the right orientation. Curved sides toward each other, flat sides away from each other. Here's the edge on view. Curved sides toward each other, flat sides away. So flat sides point out, curved sides toward each other. They're like symmetric. They're like mirror images of each other when you set them in the lens in the slot.
Yeah, we need a longer cord, but we don't have it.
You see someone less clumsy. Need someone not quite like me up there. That's good.
Somebody who looked at their feet.
The curved sides are toward each other on the inside. Make sure you get them seated in those slots nicely. Push down all the way. Sure. I actually thought when someone did a YouTube video, they actually recorded it on 2 fingers and holding each other. You can come together, merge, someone got that with the Galileoscope. So, I don't know how to practice it, but it's a good video. Now, okay, I think, how are we doing? Almost everyone got those lenses together? So once you get those together, you can put the second half of the eyepiece tube together, second half of the eyepiece assembly together, and there's some rings. There's a big ring here marked O, and a little ring marked P, 2 little rings marked P. Take one of the rings marked P and the big ring marked O. The big ring marked O goes on the wide end. The little P goes on the other end. There's a second ring marked P we'll use later, so don't worry about the second ring marked P yet. And once you get those two together, you can actually give your scope a quick test, put the eyepiece in, try to focus it. It'll work like that. Straight out of all parts. Again, these scopes have a near focus point of about 20 feet, so make sure to focus on something far away. You're working way hard. Does everyone have looks like everyone else, almost everyone has the scopes done at this point. 9 people have gotten focused successfully. You got that focus? You got it focused? You guys got focused? There you go. Almost everyone's gotten a focus. You actually look outside too. Look how far you're away. Yeah. Sure, we can open up some windows. Connie's going to open up a window if you want to look outside and see something farther away. Yes, sir. That's next up. Don't forget to put this guy on the front of your scope. Okay, now we're going to do one more. We're going to do the other eyepiece. So watch closely. The other eyepiece is some ways it's easier, some ways it's harder. It's easier because you only have 2 lenses instead of 4, but it's harder because the lenses are smaller. So like there's one way it's easier, one way it's harder. So we're going to take the other lenses here, these last 2 lenses. The red one, the top one, if you have it like this, is a double concave lens, and the bottom one is Plano convex. And again, you might need to feel that bottom one to feel which side is flat and which side is convex. Again, make it illustrate with the convex side up, match it with the concave lens there. It's a very similar idea. I'll put that down there, that'll hold it together good. Oh, that's it. got the part. That's okay. A lot of people do that. That's a common one. But fortunately, an easy one to fix, too.
On this one, the flat line goes.
I'll get that next slide. So once you get these two lenses together, the way I always remember this, take out the other eyepiece out here. This end of the eyepiece out is very wide, right? I call that the fat end. And the flat lens goes toward the fat end. So they both start with F. That's how I remember it. The flat lens goes toward the fat end. And we'll come around and make sure you get them into the correct direction before you put the two halves together.
This one is supposed to be Play-Doh on next.
I think actually technically look at there's a very, very light curve respect to that one. It just, very few people, I've noticed that, but very few people notice that, so I just like to say, that's pretty, yeah, that's something that's pretty observant here, but I think you're all right there, I think it's like how coffee, just barely. Then when you put these lenses together, go ahead and put the, once you get these in properly, you put the eyepiece together. This is the Galilean eyepiece. You got a capsule on the end, the other key ring on the bottom. And you'll see a very different view through this lens than you did through the first one. But they still enjoy seeing the contrast. And this is what Galileo saw. That's what's on the other end here. This half was on the other end. Got it? Even though it's small, I can call it okay, so that's actually Barlow. That's not useful to use Barlow. So what do you notice differently with the Galilean eyepiece? What's different about the image? Small field of view? Little less magnification? But there should be one really obvious there. It's upside down, right? The plot is upside down, Galilean is right up. Galilean will have small field of view. piece we have not used yet. We have a Barlow tube. Small tube that looks like, can I borrow this? Tube that looks like this. If you have a tube that looks like this, take your Galilean eyepiece. So remove the cap from your Galilean eyepiece. Put it in one end of the tube. That goes in the other. Then the whole assembly goes in there, and that's your 50 magnification. And then you now have a 50 magnification telescope instead of 25.
I understand Spanish.
I know. That's why I was prompted to talk to you.
No problem.
So I'll be back in like by half an hour.
Okay, you will miss the break. Wait till we are having our meeting. So go outside, all the way to the end of the building. Then there is another building with rooms, and then a big one. You'll be at the very end of the building. Go downstairs. But I will come here at 4:00
One, I think it's just that. Then it's
We'll come back at noon.
okay.
If you're ready, you can be here. I'll wait for you here. Okay, I think we're about to move on here. We can have a seat again, please, and quiet down so we can wrap this session up. We need to get on to the next session here shortly. You're having too much fun. This is good.
Yeah. We come on back and gather around quick so we can wrap up here. Connie here? Yeah, Connie's here. Okay, listen up, please. Come on, have a seat so we can wrap this up. You'll have time to play with Galileoscopes all day, I promise. So, anyway, I wanted to just let you know these Galileoscopes. These are the ones that are still available for purchase. Galileoscope.org. The price has gone up, but you can get discounts. The price if you buy one is not a very good deal in my opinion right now. They're like $49.95 for one, but they come in boxes of 6. So if you would get your friend to order a box of 6, Then they're $150 for a box of 6. The price, they're virtually half price by the box. So by the box, they're a pretty good deal. So my advice is, like, if you want one, find 5 friends who also want one and order them that way. I also mentioned that company Learning Encounters earlier today. They have, they make that Cosmos camera. They also make a star diagonal for the Galileoscope. And I got a sample of that too. Which the Cosmos camera I like. I have a fairly good initial feelings about the star diagonal. It's a little bit dicier because the way they did it was they actually give you a second objective lens. So to use diagonal, the Galileoscope apart, replace the main lens with their lens, and then build the star diagonal, and it's about 55 magnification set, 25 to a much smaller field of view. You have some comments too.
Well, if you would give the diagonal, because the diagonal is mildly useful, but if it works, if you use the Barlow tube as an extension tube, you can continue to use other eyepieces in there just by using that as an extension tube, because I think it's a 550 instead of a 500 lens that they replace it with. And the other piece that I have found to focus this rather than pulling on that tube, if you kind of turn and roll it, twist and roll it, you can be more precise rather than trying to push and pull. And then if you're using it to teach optics, the fatal flaw is that little quarter 20 nut, because that's easily lost. So what I do is I just carry a little baggie of quarter 20 nuts with me, because it becomes a useless piece if you can't mount it on a tripod.
Yeah, we made these eyepieces.
Oh yeah,
remember?
Yeah, I saw mine we made a couple years ago too. Who did that workshop a couple years ago? Kevin?
Kevin.
Yeah, I still have mine.
And it's Leo Science Lab.
Leo Science Lab.
Leo Science Lab, all one word.
Okay. And just one or two more quick things about the scope here. Some of you might have, one thing we do with the scope at public events, this is a fun little game we play with people. We'll set up 2 of them next to each other at public events. One with the fossil eyepiece and one with the Galilean eyepiece next to each other. Point is something, the same thing. And we'll have people look through both of them. We'll tell them one of these scopes is set up the way Galileo did, an eyepiece like he used, and one is a modern design. Which one do you think is which? And most people, what do you think most people think? They see one that's the Galilean eyepiece and the fossil. What's the difference between the views and which one you think an average person would assume is the modern one? Your average person looks at them and says, oh, well, this one's upside down. We're smarter than that. Surely the right side up one's the modern one. Galileo was so stupid. His was upside down. We're smart now. But no, actually the modern one is the inverted image. Galileo did have a right side up image, but if you notice, there's a very small field of view, right? Only 0.4 degrees, less than the size of the full moon. The fossil eyepiece is 1.5 degree field of view. Nice big field of view, easy to find stuff in the sky. So it's very much easier to use. And of course, many of you have seen we mounted them on tripods, and we'll take the last couple scopes and put them on tripods here too. We'll leave them set up so you can play with them during breaks and stuff throughout the day. And if by some chance it happens to clear tonight, we'll bring some over to your so you can look through them there too, for people that are over there observing. And Connie, you didn't mention about the prizes in your talk, did you?
Only a little bit. We're going to, instead of designing hours that are running, place that instead of like 5 representatives, other 5
Okay. Yeah. So we will raffle off some of the Galileoscopes, so someone might have a chance. And tripods. You can take a tripod home too. So, and I think the one rule we talked about was you can't win one of each, or win one or the other, right? So if you win a Galileoscope, you're not in the running for an arc guys and vice versa. So we won't be raffling those off at the end of the workshop here. So, but the next couple extra pieces, that's a great question. I was just thinking about how to handle that. It'd be nice if we had little baggies for them or something. What? That's a great idea. Let's just throw this little extra piece inside the baggie that the stands are in. So the extra piece is going in that baggie stands are in. Now, I'm going to give you a tip. If you take a Galileoscope on a plane, take a Galileoscope on a plane. I personally have a rule when I travel. I never ever check a bag. But Galileoscopes will fit in a standard 22-inch carry-on if you push this all the way in. You don't have the Barlow in there. All you have to do is take this off, fits in your carry-on. Just perfectly. I've traveled with these in my carry-on luggage before, so I know it can be done without too much difficulty. And GSA does not subject you to unpleasant searches for doing it either. So you'll be just fine doing that. Let's put the extra pieces inside that little bag with the stand. Put the extra eyepieces and Barlow simply in whatever you have it there. What? Just the fossil lens in there right now because that's what you in there right now. So if your scope is not on a tripod, we can move it over there. If your scope is right there, why don't we you put the baggie inside the big white box, take the big white box and put it over by the scope. The other stuff can be thrown away. Yeah, I'm done. I'm putting up and going to so you also open up, I put the extra boxes away. Once there's a teaser box, put the extra pieces in there. The other one is going over here. Let me help you with that.
Thank you. Please stand by.